Hi folks, we're going to take a look at page 106, 10C, and we've got this limit here. It's an interesting one because we do have an absolute value as part of the function that we're taking the limit of. So clearly there's an issue because the denominator is approaching 0, and we check the numerator. So 4 minus 2 is 2, minus another 2 is 0. So this is approaching an indeterminate form, 0 over 0, which means the limit may or may not exist in this case here. Okay. However, if we want to investigate what's happening as x approaches 2, hopefully would like to do some algebra. Fortunately, because of these absolute values, we can't operate on these expressions directly. So as I suggested, the first thing I'm going to do, so let's say, I call this function here f at x. First thing I'm going to do is I'm going to rewrite f as a piecewise function. Okay. So here, where things change are when x is equal to 2. Okay. So we know that when x is greater than 2, the expression inside the absolute value is positive. So the result of the absolute value will just be the number itself. So this is going to be equal to x squared minus x minus 2 over positive x minus 2 if x is, now here be careful, if x is greater than 2, notice we don't put the greater than or equal to 2 because we don't really care what's happening with this function when x is equal to 2. In fact, it's not defined when x is equal to 2. Okay. Now, when x is less than 2, the expression inside the absolute value is negative. So we have to take the negative that to make it positive. So this is going to be equal to x squared minus x minus 2 over negative x minus 2. Now again, very important to put our brackets there, or to at least do the algebra in your head. So this will be the case if x is less than 2. So since this function behaves differently to the left and right of 2, we have to deal with this using one-sided limits. Okay, so we'll start with the left-handed limit here. So as x approaches 2 from the left, and we're going to be using this expression since this is what it's defined as for numbers less than 2, and we're approaching from the left, so from numbers less than 2. So I'm going to be using this expression here. So x squared minus x minus 2 over negative x minus 2. And now we can use our usual methods for solving these limits that have an indeterminate form. In other words, we do whatever algebra we have at our disposal. In this case here, factoring. So this is just equal to x minus 2 times x plus 1 over negative x minus 2. And as we hoped, we have that this limit will exist because this is equivalent to the limit as x approaches 2 from the left of negative x plus 1. And this is continuous at 2, so we can just input the function value. So here we have negative 2 plus 1 is 3, so negative 3. Okay, so this means that the left-handed limit does exist, so step 1. Now we need to see if the right-handed limit exists and make sure that it's actually equal to the right-handed limit. Make sure it's equal to the left-handed limit. So let's find the right-handed limit here. So x approaches 2 from the right. So now we're going to be using this top expression because this is what the function's defined for values of x just greater than 2. So I'm going to be using x squared minus x minus 2 over positive x minus 2. And just as before, I can now solve it using algebra. Of course, I could have just written out the factored form right away since I've already done it. And yet again, we do have some nice reducing, which means that this function will indeed, this limit will indeed exist. Okay, and again, x plus 1 is continuous at 2, so I can just input the number. So here we have 2 plus 1 is 3. But here we notice that the left-hand limit, as we approach 2, is not equal to the right-hand limit as x approaches 2. So that means limit does not exist. Okay, so again, as I strongly urged you to do in class, anytime you're dealing with a limit that has an absolute value function in it, you're most likely going to need, unless you can evaluate directly, you're going to have to rewrite this function as a piecewise function and then deal with both sides of the limit separately. Okay, that is it.